to the phone lines, we can connect it to the grid of the house, we can connect it anywhere, we can put a plug-in on the outside and let them do it themselves. But to logically get it to that point, we're gonna have the PV, we're gonna have the charge control, we're gonna
Yep.
have to have some sort of battery,
Yep.
and probably one fixture.
Yeah, that's reasonable. That's a good
And
entry level.
That's
Yep.
the base foundation.
Yep.
I'm thinking, from my experience, we make it, and I wrote it into my part, we can take it out, but we make it mobile, we make it
Yep.
in a case, so we don't have any packaging material.
Yeah.
It's like, it sets in like Johnny Walmart's corner.
Yep.
His Walton shop.
Yep.
With, on the wheels, so that you can basically open the handle and roll it right out.
I love it.
It doesn't come in, there's no styrofoam package.
Mhm.
There's no box, there's no cardboard box, which costs money to do all that.
Mhm.
It's just basically the unit.
I love it, man. Nice. There's probably some law that you have to use a cardboard box. All things must be shipped in boxes. I was in New Orleans a few years ago for a scientific conference. It was a biomedical engineering conference. And the next conference that was coming in was the International Society of Packaging. You know, and you got to know there's packaging engineers and packaging technologists that figure out how to get the styrofoam and the plastic and the paper all
We've
right.
had biodegradable packaging for years now, but apparently it's too expensive to use on a large scale because we don't.
Yeah, I think most of the cellophane and the plastics, and they're coming out of the oil industry, and to the fossil fuel industry's credit, I think usually they figure out how to use every last drop of that crap. You know, it's going to go out, maybe it's going to become tar for the roads, maybe it's going to turn into plastic, it's going to turn into fuel. It's got to go somewhere, and I think they're able to just, and so what would have otherwise been waste, they turn into materials. You know, they turn, and so I think they've kind of got the waste thing figured out already with their, whereas, I don't know, maybe the biomanufacturing folks just aren't quite there yet.
Well, can we make, what I'm thinking is, can we make the solar just the little box?
Yeah.
We've got?
Yeah,
And my idea was, the little chargers for like the Ryobi?
yeah,
Those little charger boxes?
Yeah.
Are those AC or DC? Because you plug them into the AC. They're basically an AC converter to DC. right?
yeah. It's going to have a, well, I guess it's a rectifier. It's a rectifier to go from AC to DC.
Yeah, it's DC.
Yeah. But I think ours should be simpler, because we're just going DC from the PVs into the battery, then into the portable battery, and then anything that's left over goes into your energy storage system inside, which for now, I think should just be well, I was
You're
thinking,
gonna have to have an AC converter on that,
what?
because everything runs on AC. I
Oh,
mean, if you do, my idea, if you're really wanting to do that plan.
Yeah.
Okay, I'm gonna use blow dryer.
Yeah.
Toaster, I'm gonna use, a clock on the table. That's all been set up to run on AC power.
mm-hmm,
So if we're running a DC power into the house, into a DC battery, it's gonna have to convert to AC.
Yeah.
To be able to use it.
Yeah.
Otherwise, you're gonna have to make a whole new industry of DC materials, which you have them. You got the DC batteries to plug into the Ryobi.
mm-hmm,
But my idea was, why go to all of that lengths when you just put the AC converter in there and let them plug their own devices in there, let them plug their own chargers into it, let them plug all the other stuff. All we are providing is a pack to get the electricity.
Mhm.
You have to get to the point from our pack to your plug-in devices. If you want to plug your toaster in, that's fine. We've given you the ability to do that.
mm-hmm.
But we haven't given you the toaster, because otherwise we're gonna have to make a whole bunch of stuff.
Yeah, I guess I would, so you're envisioning, so I've just got our, here's our PV. Let me put a little charge controller in here too. 'Cause that is a very critical question that you just brought up. Format, shape, fill, no fill. So this guy here, well, let's do it this way.
That's even gotta go.
Upstream, yeah, this is our charge
upstream of the
controller.
light.
Ah, yeah. And maybe this guy, okay, so then this is going to be our charge controller. So we're coming out of the PV, going into the charge controller. Let's just pop it over here. And then we're coming out of the charge controller, going straight into the battery. All right. And then from the battery, we're going to go into our little lantern. All right, so that's pretty simple. PV, charge controller, battery, lantern. Now, if your battery's full, you go into this other charge controller, right? Because we've got the bigger battery inside, the overflow storage. Now, I've got a big fat lead acid 12 volts sitting there, but we're thinking maybe it'd be better to go lithium ion. Is that, where are we on that indoor dude?
Well, if you're going to market this to a place that doesn't have electricity, that can go in and put the lights on,
Yeah.
lead acid's probably the way to go, because you're gonna be more cost effective, and as long as you keep them charged up
Yeah.
every day to a nominal amount,
Yeah.
you're gonna have a pretty good lifetime.
Yeah.
But if you drain it, if like you say, one day you were working hard, you didn't want to worry about turning chargers on, and you just left it there, you were just gonna flip your lights on in the grid.
Mhm.
A couple of days lead acid would be uncharged, you're losing the charge capacity.
Yeah. So I agree. I think and weight's not an issue here either, so I think lead acid's a good solution.
For grid connection, but I'm thinking we market it as, okay, we've got the one package, we've got the lantern, we've got the charge controller, we've got the AC converter in the suitcase-like thing.
Yep.
That's mounted on the bicycle like trailer wheels.
Sure.
That, you know, you can get over the rough terrain.
Yep.
Even make it so you can hook it up to the back of the bicycle like a bicycle trailer.
Okay.
So, because you got India, you've
Mhm.
got Africa,
Mhm.
I don't know much about China, probably a lot of bikes in China, but I know Africa,
Mhm.
the main mode of transportation is bicycle.
Mm-hmm.
Okay, so we've got our photovoltaic array, we've got our charge controller, we've got our battery system, we've got one lantern, and we've got an AC converter in it. Okay, so you've got plugs in the side of the case, so if you want to plug something else into it, you can.
Okay.
But we don't provide that.
We've just got the outlet and the inverter.
We just made it so that you've got the power. Now you gotta go get what you need to plug into it.
Okay.
So basically, you've gotta market everything there. So that's the one kit. That's one kit for the rural, okay?
Mhm.
The next kit is gonna contain a little bit more. You're gonna have the big lead acid battery. You're gonna have the second charge controller.
Oh, wait. So the smaller kit has an inverter also?
Yes, it has an inverter.
I'm a little skeptical about that, because if you've just got this one little rinky-dink portable battery and you stick an inverter into it, it's done. I mean, you're gonna get 30 seconds of toast out of it.
You're gonna have the big lithium ions in the bottom of your battery pack, though. In the bottom of your charge station, it's not a little tiny thing. It's you open it up, you can pull your photovoltaic array out, set it on top,
Yeah.
twist it open, it's got, you might even have another one that you can put there.
Yeah,
But the initial one just got your photovoltaic array.
yeah,
Okay, it's gonna go down in to the bottom, and your bottom is gonna be basic batteries, that's where.
right.
It's gonna go through your charge controller, into your batteries, come out of your batteries into your AC, and have your AC converter, but it's also gonna have your one illuminated lamp in there, your portable that we've got, so
Yeah.
you can pull that lamp out. Okay, that is one case
Yeah.
on the wheel.
Mhm.
Okay, your other case is going to have that, all of that in it, plus your second lead acid battery that you want to put in your structure. It's gonna have your cable hookup, so you could hook it up to your phone jack, or just run the cable into the battery through a nominal hole you're gonna create. So if you don't have that cable system.
Oh, I see, so, I got you. So one system's just standalone, perfectly portable, nothing. The second system starts to get inside the house a little. Is that what you're saying?
Yeah,
Okay.
or the renter occasion, and you've got more storage capacity in the second one.
Okay.
And, you could even ramp it up a little bit and put two.
So both systems have an inverter, okay, is that good? Are you,
Yeah, it's just.
Along for the ride?
Trying to write up some of the technical type stuff that you asked me to write up, the data analysis, and it's just hard to do that without knowing exactly.
yeah, I think I'm clear.
Stuff all comes together.
Well,
I think I'm clear now. I think I'm pretty clear. So we've got, here's, this guy right here is the box.
Okay, now take the one battery, the big battery, and put it over into there too.
Okay,
You're gonna have the big battery
okay,
in there, which is probably, the box is probably gonna be lithium ions. You would probably want in the portable.
okay, then the portable over here, we got lithium ions, okay. Sounds fine to me. I'm just gonna get a little, cute little image of that for now.
$800 for that big one.
Hey, look, this just looks like a standard,
12-volt.
how about this weird looking one? So you're thinking the LI is in the portable unit?
Yeah, and then your lead acid will be in your
In-
stationary, because,
Okay.
or would the lead acid be in the portable and the lithium be in the stationary?
Well, it's a good question. Maybe there's two options. I mean, maybe the battery technology doesn't really matter that much.
Battery technology is what's gonna make it break.
The charge controller for the lithium ion is going to be more expensive, for sure, and
What's the difference?
more likely to fail. The rate at which it gets charged. The way to think about it is, I use an analogy like all the chairs in the classroom are sort of little sites where electrons can sit inside the system, and if you just try to jam everybody in the room all at once.
Bottleneck in the door.
They bottleneck in the door, they, you know, they kind of sit on the aisles, no one can make it to the middle seats, but if you just kind of like let them trickle in more slowly, then the whole room can fill up more quickly. It's the same thing with the discharge rate. So, you know, and it could be that, you know, the charge controller might, you know, push what it thinks is a full load into lithium ion, and then those electrons come and settle down into their new locations. And then it says, hey, look, I didn't get as much voltage as you thought I did, give me some more. So there's a lot of kind of back and forth talk back between the charge. So it's two different charge controllers, and it's with, I mean, the lithium ion needs a lithium ion charge controller, and the lead acid needs
Well,
its.
you've got two charge controllers. So-
Yeah, so the question for us is, what's the entry-level system look like? Is it a lithium ion, is it a PV, is it a lead acid that you can drag around your bike in the suitcase?
I think the entry level would be the lead acid.
Yeah,
Because if you're dragging it around a suitcase on your bike, you're probably gonna drag it to a location that you don't have grid-tied electricity.
it's gonna be easier to swap out too if the thing conks out on you, because someone else is gonna have their lead acid sitting there like, oh man, mine died, can you hook me up? So maybe, yeah, okay. And then maybe the lithium ion, okay, so let's do that.
For the more industrialized person, and that lead acid battery is probably gonna cut your cost a third.
Yeah. So let's do that. So charge controller, PB, for your lead, charge controller, lithium ion. Now, are we saying, so this thing will also have an inverter, yeah? Okay. Guys, you know what the really nice thing about this system is? Andrew McChain is building one right now. I'm dead serious. So we already have a prototype.
Or you can tell us what works and doesn't.
Absolutely. You know, and that's why I love my alumni. Okay, so let's do this. Let's take. I'm going to turn off my email so I'm not bombarded by that. Oh, format, shape, solid line. Soft edges.
Technical problem, let's see with this. Can you, from one of the portable solar units, can you get enough charge to charge a lead acid?
Oh,
Can't you charge a lithium ion on a much smaller voltage than lead acid? I don't know if that's true, but.
That's in the charge controller.
I-
Put capacitor in the charge controller, and the capacitor, once you charge it to capacity, you'll start pumping.
I think, I think as long as you're above 12 volts, and the way we dialed ours in, we were gonna be at 14, as long as you're pushing it more than 12, you'll be able to charge it. Where are you getting that from though, Adam?
But each individual unit is not 14 volts.
Yeah,
Oh, it is?
yeah. Yeah, let's go back to, here, let's go here.
Okay, sorry.
Yeah, let's go back to ML Solar. Let's go back to ML Solar. Solar panels. Oh, I've got charge controllers here too. Solar cells.
Yeah, see, we're not reinventing anything. We're
Oh.
just packaging it.
Oh, absolutely, yeah.
Making it so that, somebody can use it.
Yeah.
Right away, within minutes.
Yeah, yeah. So the other thing is do we buy a panel or do we buy cells? I kind of want to buy, I just,
We talked about
this is me like wanting to make things harder than they need to be. I want to buy the cells and damn things. Because I like your little, fold out flower idea, all that. I mean, if we could get
Well, once we got the one panel done, then that would be the mold for the other four on the thing, and that would be
Yeah.
the mold for every other one.
Sure.
You wouldn't have to buy, or you wouldn't have to make more than just the one major mold, because you're gonna come out and swivel, mold like a flower.
Yeah. But just to get back, Adam, I think what we're planning on doing is, let's just take a look at these. So we can do 3x6s, 6x6s, and then I don't know what these sizes are. I think it's just more of the same, just without the tabs. But I think from our,
How many did we need with the three, because we did all our calculations with the 3x6s. And that should be in the middle shell. That was the data stuff that I was gonna have you put together.
yeah,
Started looking at that last night, and I was trying to remember how we.
I thought I had a, yeah, let's look at it. Golly, you're kidding me, just go away, go away. Phone cord resistivity, was it a Excel?
I think it's in the
Down.
EPA.
It's the figures, I believe.
This one?
That might be one,
No. Oh, yeah. Powers.
And that's just one of them, right?
That's what I was trying to remember last night, I was looking at this, like, trying to make sense of it all.
Yeah, this .55 square meters,
It's 20 inches, wasn't it?
yeah. I thought I had an Excel on this too. Let me just find it. It might be in, I might not have pasted that one over. Is it here or, no? Power and energy.
1.55.
Oh, yeah, here we go. Okay, so that's 3 inches, so this is the length in inches. Here's the width in inches. Here's the, that's the area in inches, area in square inches. Squared. 26 of these things, is that what we came up with?
It says 25, but
26? Oh, maybe
Does it say-
yeah, I think the resolution's not that good. Here, let me pop this up a little, sorry. So I think we came up with 26 of them, because if we go back and look at the voltages, let's just see what the voltages are on the 3x3s, 3x6s. Average voltage, so 0.5 volts.
We're gonna need,
So that gives us 20, so 26 gives us 13 volts. That's how we came up with 26.
okay, but we're gonna need to put 28 of them. We're gonna have 28 of them in the array to make it so every single panel is gonna come out the same, because you're gonna put 8 of them in each panel and square it off.
Okay, let's look at that.
So 8 times 4 is 28.
Yeah, that's good point. Let's look at that. So let's insert shapes. Let's just do this. So that's a 3 by, let's just call that a 3 by 6. So there's a 6 by 6. Let's make that border. Yeah, I'm not liking getting used to the. Let's make a black line on there. Like a thick one. Okay. So there's a square. There's 2. And copy paste. There's 4. Copy paste. There's 8. We've got a square again at 8.
Yeah.
God, the next square that's going to happen is 32. That's going to give us 16 volts.
But try to.
Is that too much?
Try to divide those out into 26 and get a square. And have it so you can make them all the same.
Okay.
That's why I say we're gonna have to put 28 in to make the manufacturing with ease.
Let's just pop up to 32. Then we'll start taking away. So you want to get rid of 4 of them. Oh, so are you just going with something like this? So you end up with a rectangle. I guess, obviously, I didn't make the aspect ratio correct there, but. There's 28, if we just do it this way. Is that what you're thinking? Is there another way to? Because now we got 6, 12, 18, 21 by 6, what did I say? No. 6, 12, 18, 21, yeah. And here's 6, 12, 18, 24. So we got 24 by 21. You know, basically, if we subtract 3 inches over there, we get 3 more over there.
I'll have to get, I meant 7 on the panel. I have to get 7 on the panel somehow, and that's what you got.
7?
You have to get 7 cells on the panel. When I was calculating my brain wrong when I said 8 because it's 32. So you're gonna have to get 7 on the panel, unless you wanna go with the 26. You're gonna have to see how it doesn't work. with
Oh,
the
you're saying
26.
7 times 4 to get to 28?
Yeah.
Yeah.
Because how can you get an even number with 26?
An even number. Oh, divided into, because you're imagining 4 separate little
Well,
panels to make the array.
I'm imagining one panel,
Yeah.
not the 4 panels.
Okay.
So you've got one panel, how do you take the one panel and make that so you can make 3 more exactly identical to the first panel that you make?
Yeah.
When you make a mold,
Yeah.
to ease manufacturing, you don't want to change anything.
Right, right.
All you're gonna do is you're gonna shove a screw right down through a swivel so they can swivel out
Uh-huh.
and put a lock on.
Yeah. So if we did 6 times 4 is 24, I don't think that's enough. 24 is only gonna get us, so
That's why I was saying we're gonna have to have 28.
let's just go 8 times 4, 32. What's wrong with that? Is there anything wrong with that? It's gonna be too much voltage? That's what the charge controller's for.
That's what the charge controller's
Okay,
for.
all right.
And that's what your AC converter's for too, you know, you've always got that plug-in for your dump load. And your dump load's basically running your light inside your house 24/7. Or, you know, running the cord over your house, going out and making toast
Mm-hmm,
with that dump load.
mm-hmm. Okay,
Because it'll make the ease to manufacture so much easier if we just have the one mold, is what I was,
yeah, no, I'm with you. Let's make this, okay, so now we've got these 4 guys, copy, paste. They're each, so now they're each, what is that? They're a foot, they're each a foot wide. And they're gonna be packageable into the suitcase, right? Is that kind of the idea?
that's a foot square, right?
Foot square, yeah, foot wide by a foot tall, yeah. We've got a little pin in the middle. Whoops. So they fold out in our fancy little flower. That's why I like Solar Garden, but it's okay. Solar Night, it's all right.
It might already be taken.
I know.
We haven't did that research yet.
No. Okay, so I can move that. And that's essentially what we have up here, right? So that's our little deal. It's going to sit on top. So now it's 2 feet by 2 feet. And is that a reasonable size for this suitcase? 2 feet wide? Can it go wider? What are you thinking for the whole, like, the overall dimensions?
2 feet by 2, it's only a foot. The thing is only a foot,
Oh.
it's probably gonna be that wide, so it'll fit right in there.
Okay.
Because you've got, you know, if I had a foot, I could show you, you know, a piece of paper.
I'm with you.
You've got 11 inches here, that's another inch probably.
I think I can draw a little 3D here. I should be doing all this in CAD, but I'm so much faster in Excel. Somewhere there's a 3D format.
Yeah, see, that's how wide it's gonna be. That's the dimensions,
Of the whole box?
the whole box.
Yeah?
Well, not necessarily the whole box, because you're gonna have to,
I mean, I'm just thinking all this other stuff has to go
Well,
inside of it.
I mean, you got your charge controller.
Yep.
First thing you gotta worry about is these will sit on top. You'll have these sitting on the top.
Yep.
So it's stand up
Mhm.
thing. You'll have this sitting on top, and that's, you know, it's gonna be like this. And then depending on how thick we make them, the panels itself, you know, because you gotta give them space.
Yep.
to Flux. So you're gonna be looking at probably that wide, that square, probably by that deep, and you can set them in the thing. You've got a little, like, your rod that they go through, it's
Mhm.
already connected to them, so you're gonna have a little bit more space out the other ends of it. And you can basically screw that up in there somehow, so it'll stay and kind of hang, so
Yep.
it doesn't get damaged in there.
Mhm, mhm.
Has some sort of packaging.
Mhm.
In the bottom of that box, because you want it all your weight down low, you're probably gonna have your batteries in the bottom.
Yep,
Okay, above the batteries is gonna be your charge controller, and beside that, you'll set your lantern. So it'll all be right there. And on the outside, you got, your little bicycle wheels.
so this guy can be the battery sitting down here, right? This 3D thing is gonna kind of break down in a second here, but, you got your battery, you've got your, let's just make the panels, blue for now. Let's make them, let's go to my 3D. 30. So the PV is going to go up in here too, right? The inverter. Let's make that a different color. I don't know, maybe that's green. And it's going to be a little thinner. Oh, I don't want green on that guy. Let's just make that like 100. Inverter, different color. And then the charge controllers, and there's two somewhere,
And the inverter and charge control,
one little box.
one little box.
Yeah, makes sense. And then, need some wheels on there. Let's see if I can do this. I wonder if I can make this thing inherit the properties from a, square to a, no, probably not. Insert shapes, here's the wheel. Wheels are there.
Should put spokes in.
There's just gonna be one panel that's folded into its parts inside the box.
There's gonna be 4 panels.
4 panels.
There's 4 panels stacked on each other, so they're gonna be like this. And when you open them up, just pull it out. Like so, the one locks there, then the other one locks there, and then the other one locks there. See, we don't even really need to go with the square, but it's gonna look like that.
Oh, yeah.
It's gonna be square.
Those are gonna be one, 4.
4 of those, yeah, I think that's what we got.
Those are gonna be just the base model, and then
30, yeah, so 32 cells, 0.5 volts each, it's gonna get us to 16 volts, more than enough to charge the 12-volt battery. There's your 1, 2, 3, 4.
on the side of the box,
Yeah,
why don't you put a 4-plug outlet?
absolutely.
A weatherized 4-plug outlet.
GFCI,
Yeah.
yeah. I like that. Let's do that as a little text box. GFCI. COU.
Now you
GFCI.
can take this get an extension cord, set it outside your house, plug your
Mhm.
extension cords in, run them into your house, into your little thatch hut,
Mhm.
is what I was thinking.
Mhm.
And you can watch Looney Tunes on a little small TV, you know, while the sun's shining out there.
Mhm.
Your
Battery sitting there.
The
Yep.
battery's sitting there, you know, at full charge, and then once you get full charge, you're basically the chief in your village, and you charge admittance to the thatch hut to watch movies.
Nice.
Are we still trying to do the thing where you can bring inside multiple units, hook them together to charge your stationary battery?
I think that's phase two.
That's down the road. Right
Yeah.
now, we're just looking at getting the power and, you know, and even in the phase two, I believe there's a part where in the application process, you know, look, we're looking at studying the phone cord system.
Mm-hmm.
We did some research on them, it's applicable, we need more information, basically.
Yeah.
Every scientist says needs more information. So we get the
You're catching on, man. Yeah, pretty good. Nice.
It's the funds to study, but we're just making the base model, you know, and we are giving power to people that wouldn't have it otherwise. And, or power to people that want to lift their carbon footprint. Should I put aluminum in there? I looked at, maybe it was Lovin's that did all of that.
Oh, embodied energy?
Yeah, how much energy it takes to make so much aluminum, or how much aluminum there is recyclable in the country that we don't recycle.
Yeah, yeah. That seemed like it was something that EPA was interested in. I think they do want to know that.
Recycling and plastic recycling, you know, can we recycle plastic to make these panels?
I certainly hope so, man. I got so much of it. Missoula has more than enough.
So we've got the price of our 32 pounds, we know what that's gonna cost, we need that.
Yeah, there's a lot going on this website. I think we need to figure this out, in a pretty big way. Do you mind digging into this economics a little bit, Adam? I think this might be a good job for you, is to look at the different options that are available at ML Solar, with and without tabs. Maybe get on the phone with these guys and figure out what's the best. Because I think we have money right now. We have more money than we know what to do with in energy technology. So we just need to go out and start buying some of this stuff and start tinkering.
Give me a job.
I've got a couple job openings.
Do you?
Yeah, I have several.
But do I have to have a doctorate?
Nope.
No? The teaching jobs?
Yeah, and student jobs too.
Oh, really?
Yeah.